Hello, it's Mr. Skis. I am recording this video for you to watch on March 8th. So, hello. Hopefully you're watching this on March 8th in class. Today we are doing lesson 8.4. You should have just completed the 8.3 daily quiz with the substitute. Thanks for doing that. Thanks for doing that in a timely manner. And now here we are about to do the notes. So if you don't have it pulled out already, go ahead and pull out the 8.4 notes. Um, and a couple other announcement things while I'm thinking of it here at the beginning. Let me go ahead and switch. I had them written down here is that, of course, there'll be the assignment after this for 8.4. But also, I just wanted to mention the fact that 8.5 marks the end of the unit, and then we'll be reviewing and testing next week. Okay? So that's the lay of the land here, and that unit 8 will be our first summative for quarter 4. We are on the major downhill. The semester is almost over. So, um, last lesson that we had together, we were looking at we were looking at interior and exterior angles. And the class period before that, we were looking at central and inscribed angles. So we now know that there are these four types of angles that exist in a circle. And now we're looking at this big circle with all different types of angles, and we're just going to solve for basically as much as humanly possible. So stay with me. And if I lose you, remember you can always go back and watch this video, but try to stay with me because there are a lot of angles, but hopefully a lot of it feels relatively intuitive, common sense, that type of thing. So let's start with the given information. AC is a diameter. I'm just going to go ahead and bold that so we don't forget that. AC is a diameter. AB is 120 degrees. And CD is 40 degrees. So something I've tried to mention the last two class periods is that you don't really want to solve a problem in order. You just want to solve a problem for what's easiest. So what's easiest to me is central angles, inscribed angles. And what's also relatively easy to me is just like the arcs, making 360 for a total circle, okay? So with that in mind, let's address the arcs because they told us some arc measurements. Let's find all of the arc measurements that are left over. So AC is the diameter, making a semicircle. 120 and 60 make 180. And then there's the semicircle on the other side for a total of 180. We already know this portion is 40, so the rest of it has to be 140. And now we have our entire circle 360 degrees. So I just filled in 60 and 140. Okay? So now that we know the arcs, we can start to solve for a lot of these angles. Let's start with the central angles. The vertex is at the center, so I know that the central angle and the arc that it intercepts must be equal. So this angle 9 intercepts arc AB, and thus this is a 120-degree angle. And similarly, for angle 6, it intercepts arc BC. So if the arc is 60, the angle is 60. Okay? Those are the two easy central angles. Did I solve for angle 1 and angle 2 first? No, I solved for 9 and I solved for 6. But now I can solve for angles 1 and 2, maybe, if we'd like. These are inscribed angles. The vertex is on the edge. That, again, was what we did 2 class periods ago, and we know that inscribed angles are half of the arc. Inscribed angles are half of the arc. So this angle 1 intercepts arc BC. BC is 60, so therefore the angle is 30. Angle 2 intercepts arc CD. CD is 40. Half of 40 is 20. I'm going to keep circling around. Here's another inscribed angle, angle 8. But if you notice, it does not intercept a particular arc. We don't know what arc this would intercept. You might have another strategy as to how you might solve for angle 8, but I'm going to pause and stay with the pattern here. let's go to angle 7. It intercepts DC, which is 40. Half of that is 20. Angle 4 intercepts arc AB, which is 120. Half of 120 is 60. Angle 3 intercepts arc AD, which is 140. Half of 140 is 70. And angle 5 intercepts arc AB, that nice big AB angle, and that's 120. Half of 120 is 60. If I lost you, if I went a little too quick, I apologize. But let me just rehash maybe the last two there. I am looking at this angle and I'm seeing where it touches the edge of the circle. Everything else in the inside, I don't care about. I just care about where this chord is going, it's touching at A, and I care about where this chord is going, it's touching at B. So here's this nice, lovely angle, and it intercepts this arc AB, which is 120 degrees, and half of that is 60. All right, let's go back to that angle 8, shall we? Did you have an idea as to how we might solve for that? It's inscribed, but yet we can't take half of an arc that we don't know. So what's another strategy? 30, 120, and it has to be 30 for a total of 180 degrees in this triangle. There are 180 degrees in a triangle. 30 plus 30 is 60. 60 plus 120 is 180. I could do the same thing over here. Do you notice this triangle? I have 2 out of the 3 angles. If this is 20 and this is 60, 20 plus 60 is 80, therefore making the third angle 100. Now, why did I solve for an angle that wasn't labeled? Well, the thing is that these are vertical angles. So if that's 100, then this angle is 100. And this is a straight line making a linear pair. So if this is 100, the angle 12 is 80 for a total of 180 degrees. If you recall from last lesson, for interior angles, it was arc plus arc divided by 2. Now, I don't know about you, but that just feels messy to me. It's not difficult, it's just messy. That that was clean. That was clean. That was simple. We don't we're not obligated to solve for interior angles using this formula. If there are other methods, by all means use those other methods. So we ended up solving for the interior angles without having to use the formula. The last thing, well, a couple more things. We have 14 and 11, which I probably have already talked about this in class. I'm making this video on March 2nd in case you want me to break the fourth wall here so you're aware of when I made this. Making this on March 2nd. So there's a chance that we talked about this in class in between the time. It doesn't matter what I'm saying. The point is I might have already said this in class the next time I see you. This is a vertex on the edge making 14 inscribed. It is also inscribed, just like 1, 2, 8, 7. They're all inscribed. So the arc that's being created, there's like a subtle difference. When you're looking at angle 2, it touches the circle at D and at C, creating this arc way out here in the distance across the circle. But the thing is about angle 14 is that this chord doesn't touch the circle again. Okay? It just continues on forever. It's not even a chord. It's just this line that continues forever. So where's the arc? It's this entire thing. 140 degrees. Half of that, 70. So there's still an arc. It's just created in a different way. Okay? Where this touches 2 times out here, creating this arc, it touches once out here, and it's touching once at the vertex, creating this very large arc of 140 degrees. The same can be said on the other side, the vertex, and way out here at B, half of 120 is 60. And let's do a little double check real quick. Let's do a little double check. These 1, 2, 3, 4 angles should add to 180 degrees because they're making a straight line. 60 and 30 add to 90. 70 and 20 add to 90. 90 plus 90, a total of 180 degrees for those four angles, a linear quadruplet, if you will. I don't know what you call sets of four. Pair, triplet. I don't know what four is, but there it is. I'm not gonna fill in the blanks. If you want those blanks filled in, Miss Miles has filled them in. Oh, I didn't do the exterior. You don't really need to fill in the blanks, right? If you already have it filled in on the circle. You know what I'm saying? Angle 10. Now, we could be clever about this and try to arrive at this angle through other methods than using the exterior angle theorem. If you recall, it was big arc minus small arc divided by 2. Can I be clever and avoid having to use that? Well, I'll let you be the judge. Is being clever easier than just using the formula? I don't know. That like I said, I'll let you decide. If I were to be clever, I can't help but notice this giant triangle right here. And I know that this upper angle is 20. And I know that if this is 60, this has to be 120 because it's a linear pair. So 120 and 60 make 180. So with that being said, if this is 120 and this is 20, 120 plus 20 is 140. So that means angle 10 has to be 40 degrees for a total of 180 in that light blue triangle that I drew. If I didn't do it that way and I did big arc minus small arc, well, here's what would have happened. Here's this chord, or whatever, not really a chord, but the segment touching at D and at A. And here it is again, touching at C and at B. So the big arc is 120, and the small arc is the 40. 120 minus 40 is 80, and 80 divided by 2 is 40. So there you have it. We arrive at 40 degrees either way you look at it. So I'll let you decide. Is using triangles and being clever easier? Is just using the formula easier? You decide. Okay, let's do another one. Um, to be perfectly honest, I'll probably, just for the sake of length of this video, I'll probably leave the third one for you to do independently. And then you can just check Miss Miles' key um, for the solutions because the pattern doesn't really change. You want to use the given information. Let's go back through this. There's a nice little description over here which I didn't read, but if you like words, you can read this. It says, try your best to find all of the arc measures, then kind of go in order from easiest to hardest, and then also look for stuff like this. Honestly, I like to look for stuff like this from the start because I find this kind of stuff easy. Triangles, vertical angles, linear pair. I I like those type of things, okay? So I don't wait till the end to look for those, personally speaking. So what do we know? GC is a diameter. And I had a question about this today in class, and I just want to clarify. Even if they don't tell you something is a diameter, if you know that it's a diameter, it's a diameter. You don't have to be told. If it goes through the center and it goes from edge to edge, that makes it a diameter. So if it goes through the center and it goes from edge to edge, that's a diameter. Okay? The drawing is not meant to be misleading. So I'm going to tell you plainly, even though it's not written, BF is a diameter. All right? We can also, I'm going to write and BF. Okay? Why do we care about diameters? Because we know it creates semicircles, and semicircles imply 180 degrees on the two halves. So, more arcs. BC, 60. AG, 80. CD, 40. EF, 20. FG, 60. FG, there it is, 60. Okay. So, what are we looking at here? A diameter creating 180 degrees. That means this has to be 40. 60 and 40 add to 100, and then the 80 for a total of 180. 60 and 40 make 100, and then 80 more. Oh, but I got this 20 here. I was really tempted to write 80 here, and I'm not lying to you, right? Because I was like, oh, but there's this smidge here, so it's not 80, it's 60. Hopefully you're with me on that. For a total of 180. 60 and 40 make 100. 60 and 20 make 80 for a total of 180. Doing the arcs first is definitely your best bet. There are certain situations where you can't solve for all the arcs, and that's just due to there not being enough information. But when you start to solve for angles, then you can use those angles to then solve for the rest of the arcs, you know? So you can always go back. Angle 1 and 2 are central, the easy ones. The vertex is at the center, so if this angle is intercepting BC, boom, that's 60. And if this angle is intercepting CF, be careful here. CF is a combination of 3 different arcs for a total of 40 and 60 make 100 plus 20 is 120. So boom, 120. Now, I could have also just used a linear pair, right? I don't have to just look at the arcs. I could have said, hey, this is a linear pair, 120. So central angles done. Let's look at all the inscribed angles. We have angle 5 intercepting this BA arc, which is 40. Half of 40 is 20. We have this angle 6. And again, ignore all of this stuff in the middle. What matters is this chord is touching at A, this chord is touching at C or G, creating this arc GA, which is 80, and half of 80 is 40. Again, ignore all of this mess in the center. What matters is this diameter is touching at G, this chord touching at E, creating this 80-degree arc. 60 and 20 make 80. Half of that is also 40. Speeding up a little bit more, angle 3, half of 40 is 20, and angle 4, half of 60 is 30. There's all the inscribed angles. Inscribed because they're on the edge. Oh, no, never mind. Angle 10. Angle 10, 20, 60, and 40. That's 120. So half of that is 60. Okay, now we're done. So there are several interior angles that we have yet to solve for. Now, I'm always a fan of being clever, trying to use triangles and whatnot. But it's a little slim pickings. There's this quadrilateral, which would add to 360, but I don't know 3 out of the 4 angles. I'm missing 2 angles. This is a triangle, but I don't know any of the angles. It's a bit slim pickings. I mean, you could try to be like, well, is there a way that I can sort of, this is 60, this is 40, so that makes this 80. This is 60, this is 20, so that makes this 100. These are vertical angles, right? I'm solving for all types of things that I don't even need to know. And if that's what you want to do, you can, right? But make sure you're getting them all right. Make sure you're getting them all right. Because now finally I can actually solve for 11. Solving for all these random details. How can I solve for 11? Do you see it? There is a quadrilateral for a total of 360 degrees. I know 3 out of 4, 100 plus 20 is 220, plus 30 more is 250, meaning this angle right here needs to be 110, because 110 plus 250 is 360. Now, was that worth it? I don't know. Was that worth puzzling my way through? If you're like, yeah, that was really worth it. I don't want to use the exterior angle theorem, then fine. Do it that way. You are under no obligation to use the exterior angle theorem. Or sorry, I misspoke. Interior angle theorem. Um, but it just might be easier to be like, you know what, I'm just gonna do it the way I'm supposed to, or like what the formula says. So I'm gonna look at angle 12 and I'm gonna go, okay, here's this arc, and look on the other side and go, okay, here's this arc. The 60 and the 20 make 80, so 40 plus 80 divided by 2. I mean, that's not that bad. So you end up with 60 degrees. I mean, was that bad? No, not really. But remember, with exterior angles, or sorry, I'm sorry, I'm misspeaking there with exterior. With interior angles, when these two chords are intersecting, we're creating two arcs. Those are the two arcs that matter. Okay, and then you could do it the other way around too, for this angle or that arc and this big arc, right? You could do it that way as well. But I got 120 because this is a linear pair. Um, Now I can't help but notice that without really doing any extra work, I have another quadrilateral where I now know 3 out of the 4. At the start, I didn't. Now that I solved for these two, I now know 3 out of the 4. 120 and 120 add to 240. 240 plus 40 adds to 280. So there is 80 degrees remaining, making this 100. If I miss something, if you're like, yeah, Mr. Skis, there was like a triangle staring you in the face the whole time. My bad. My bad. There are a lot of shapes here. If you're like, man, I could have solved for 14 like many moons ago. Honestly, great. Truly. Like, it's not, there is no one way to solve for these. If you solve it in a different order, you end up solving for this angle first, which leads you to this angle. Like, there are many routes that can be taken. There is no steady rule. Angle 8, I now have this vertical angle at the 60. We figured out this was 100. 160 add to 160, 20 degrees more for a total of 180 in that triangle. How long is this video so far? 23 minutes. Okay. And there's one more triangle right here. We know this is 100. So this is 80. Well, I was gonna use a triangle for number 9, but I don't know how big this angle is. Is that easy enough to solve? It's inscribed. Yeah, it's inscribed. And it's creating this arc. 60, 20, that's 80. 80 plus 60 is 140. You with me here? Let me say this again. I'm trying to solve for this angle right here. Let me use a different color. Because I'm trying to use this triangle. Again, is this more work than just using the exterior angle theorem? I don't know. You be the judge. Truly, you be the judge. I'm not here to make that call. Whatever you feel is easier. I like triangles. I like that they had a 180. That's how I'm going to live my life, you know? So this is 60, 20, that's 80, plus 60 more, that's 140. Half of 140 is 70. So with that being said, 70 and 80 add to 150, making this final angle 30. If you feel like you need more practice with the exterior angle theorem because you're like, well, there's some moments, Mr. Skis, where you're like, where I kind of have to use it. Okay, let's do one more here. Let's do it the other way. If I draw this big angle, what is the two arcs? Big arc minus small arc. Big arc is the 80 and the 40. That's 120. Small arc is the 60 divided by 2. 120 minus 60 is sorry, I was jumping ahead in my brain, is 60 divided by 2, which equals the 30. All right. You okay with that? This video is going to be I think way too long if I do another one. I think you're probably catching on. Um, yeah. So, we have a random bit of review here, some good old algebra review in these notes to get us warmed up and prepared for the next lesson. Okay. So I'm not going to sit here and do all of these because when I come back, I will be there next class period. When I come back, I want to have a few more to do together. So we're going to kind of tease the next lesson by doing this today. Then we'll do it again at the beginning of next lesson, and then we'll really dive in to the next lesson. Okay. So the solutions are already here. So it's no secret what we're doing here. So completing the square and factoring review. So do you remember how to multiply? Let's look at number three. You remember how to multiply stuff like this together? You were probably taught the box method. So k minus 5 and 3k plus 2. I hope this looks familiar. I mean, I can't see you. I can't see the nodding of the heads, but I hope this looks familiar. And you end up with 3k squared minus 15k plus 2k minus 10. And then you combine these like terms together, and we end up with 3k squared minus 13k, because negative 15 plus 2 is negative 13, and then minus 10. There's probably a decent handful of you who know how to do that in your head, okay? But if you don't, use the box method as I have here. Now, what? How do I do this one? Well, what does 2x plus 1 squared mean? It means 2x plus 1 times 2x plus 1. So when you see something squared, it's the same thing as this. Just break out the box method. Break out the box method, and you end up with 2x times 2x is 4x squared. 2x times 1 is 2x. 2x times 1 is 2x, and 1 times 1 is 1. And combine your like terms, the two x's, and you end up with 4x squared plus 4x plus 1. I'm realizing I don't think I described. Did I describe my steps when I wrote those down? I do the box method a lot in algebra 2. So I'm sorry if I don't even know what I just said. So did I say it? 3k times k is 3k squared. I don't think I said this. 3k times negative 5 is negative 15k. I'm just multiplying. This times that, this times that, this times that. Okay? So there's a couple box method. So find the value of c that completes the square. So if you recall, completing the square from algebra 1 is where you take a trinomial meaning three terms, you can take that three-term expression and rewrite it into something like this. Okay? We are taking this trinomial and writing it as a square. That's what completing the square means. And if you want to write down my scribbles, you can. And if you just kind of want to soak that in, don't write it down. Just kind of remind yourself. Completing the square means to turn a trinomial into something like this. And there's always a quote unquote magic number that completes the square. And that magic number is always b over 2 squared. Okay, that's the number that completes the square. So what do we mean by b over 2 squared? Well, a trinomial in standard form, this is the standard form for a trinomial. Ax squared plus bx plus c. So those coefficients, this little invisible 1 here, b is negative 24, and then there's c. And we're trying to figure out what c should be. C should be what in order to complete the square? Negative 24 over 2 squared. Negative 12 squared is positive 144. So in order to complete the square, the c value needs to be 144. Let's do one more. Let's look at 10. What is the c value that is needed to complete the square? The b value is negative 36. And the formula to find the number that completes the square is b over 2 squared. That's negative 36 divided by 2, which is negative 18. And negative 18 squared, maybe I shouldn't have chosen that one. That's a big number. 18 squared is 324. Okay. All right, and the last step, factor completely. So the last step here is factoring. So how do we factor an expression? Well, factoring can be done in several ways. When there's just two, when you're looking at something that has, let me take a step back. This is a lot of review, um, and I encourage you to kind of look at all the solutions at the bottom. But when you're looking at these terms, you can see that they have something in common. When they have something in common, that's called a factor. And we like to pull out the biggest thing that they have in factoring. You might remember the phrase greatest common factor from Algebra 1. So what is the most that they have in common? They both have an x, so we can factor out an x, like so. This is leading somewhere. You might feel like this just feels like, I mean, we've been talking about circles the last 3 lessons. What does this have to do with anything? Trust me, you will see it come together in the next lesson. But we're just sort of getting the juices flowing. I'm almost done here because I'm not trying to make this any longer than about 35 minutes. Let's look at another one. Let's look at 18. Just a random one here. When you have a trinomial, sort of like what we were looking at up here, you can see the connection, right? We're starting to form a connection here. When we have a trinomial, we look at the last number and we look at the middle number and we ask ourselves, hopefully you remember this pattern because you did do it in Algebra 1. So I hope the words I'm about to say are not completely foreign to you. What two numbers multiply to the last term, which is negative 32, and add slash subtract in order to become negative 4? So, like, what do I mean by this? Well, what are some numbers that multiply to 32? 16 times 2. 16 times 2 multiplies to be positive 32. 16 times negative 2 multiplies to be negative 32. Okay. And what happens when you combine 16 and negative 2? Well, they add together. 16 plus negative 2 is 14. Okay. I'm just going to say adds instead of add slash subtract. 16 plus negative 2 is 14. Does that add to be negative 4? No. So what combination of numbers multiplies to be negative 32 and adds to be negative 4? Negative 8 times 4 is negative 32, and negative 8 plus 4 is negative 4. It's it's not luck. It's being good at your times tables and being good at mental math, right? I know that negative 8 plus 4 is negative 4. Boom. And I know that negative 8 times 4 is negative 32. It's just knowing those times tables. 2 times 4, 2 times 5, 6 times 8. Just knowing combinations. And that's what's going to make you quick. Okay. I think I'm just going to call it right there. Uh, Um, Actually, let's do 21. Let's do one more because it combines the previous two together. Do you see something that all three terms have in common? This was not the case for 18. What do all three terms have in common? They are all divisible by the number 3. So we can factor out a GCF of 3. Oops, that's my bad. I didn't take the 3 out of the other numbers. 9 and 8. So I factored a 3 out of each and every term. Think of factoring like division when it comes to a GCF. 27 divided by 3 is 9. 24 divided by 3 is 8. And then, now that I factored out the GCF, like I did in this problem, Now I can look at this trinomial and factor it like I did this problem over here. So what multiplies to be positive 8 and adds to be negative 9? Negative 1 and negative 8 will add to be negative 9, and negative 1 times negative 8, the two negatives when you multiply will cancel one another out and become a positive. I promise this is going somewhere. So I hope you were with me, and then that was a good warm up for you. I hope that is recalling some memories. It's coming back to you. But with that, I'm just over the 35-minute mark, so I call that a success. Um, you are now you've completed the daily quiz at the beginning. If for some reason you didn't, make sure you're doing that. And now we're gonna do our assignment, which is primarily made up of the big circle stuff. Okay, that's our primary concern for today's lesson. And then when I come back, we'll finish 8.5, or we'll finish the unit, which is 8.5. Okay, enough from me. Uh, have a good rest of your day. I'll catch you later, and I'll see you next time. All right. Thanks for watching.